All right, everybody, we're going to pick it back up here, talking about relationships between entities. So we talked about attributes. Now we're going to look at specifically some terminology around how we define these relationships. So we've looked at student, and we've looked at class, or section, I think was the individual section offering here. And we said many students, right, would take many classes. So student takes many classes, or a student in a section has many students enrolled. Right, so many students are enrolled in a section. A student can take many sections, many classes here. And again, we talked about these many-to-many relationships, saying we can't actually implement them. So what we need to do is, depending on how these relationships are defined, and again, this is all about the business requirements here, we need to solve these relationships. And in a case of a many-to-many relationship, we need that joining table here. So in this case, this would be the enrollment table. So a student would have many enrollments, and a section would have many enrollments. But each enrollment relates to one student, and each enrollment relates to one section. So when we look at what is the relationship between the tables, right? Again, the things that we can implement one-to-one, we can implement one-to-many. Aside from that, conceptually, a many-to-many is fine, but we need to actually break that down into what we can do for implementation-wise. So some of the terms that we're going to use is connectivity and cardinality. So the connectivity is saying, well, how is that relationship here? What is that classification? Is it one-to-one? Is it one-to-many? Or even many-to-many if we're talking conceptually. That's fine at the conceptual level. But again, we want to focus more on implementation. And then the cardinality is, well, what is the possible range that they can have with this relationship? So a student, what is the maximum number of enrollments you can have here when you enroll in a course? And, maybe there is no max, so maybe it's just star, right? You could just take classes forever if you want. But a section, right, might be limited from 1 to, say, 30. And we'll say no more than 30 enrollments when we look at this cardinality here. One-to-many, student can have as many enrollments as you want. Again, at some point, registration and counseling will say you can't keep adding credits for a given semester. But we know that, one of the pieces here, that section is a given semester for a course, so we can't really limit the specific enrollment table unless we go all the way down and through that relationship and find which semester it was and say, okay, no more than 18 credits per semester, or whatever rule we want to implement here. So the cardinality is difficult to implement at the database level, but we still want to note that as we're going through and discovering all these business requirements and say, okay, well, what is that relationship, and what is the rule, what is the number, what is the limit here? And then when we talk about relationships between entities, there are some that are dependent, right? So their existence is dependent on another entity. So in this case, we said, hey, I have this idea, I have students and I have organizations that they're a part of. So one student can be a part of many organizations. And again, really, that's a many-to-many. So this is like, we might say this is participates in, or I was trying to think of a good noun here, because we'd have our organizations over here with many, maybe we'll say members, right? Member. So you can be a member of many organizations, and an organization can have many members here. But this member table here is completely dependent, right? It wouldn't exist if there wasn't the student. Right? Because if you're not enrolling, if you're not becoming a member of that organization, then it's not going to be there, right? We can have the organizations, but if there's no members, right, this member entity doesn't need to exist. So it is dependent on the other tables. And again, part of this comes at the database level when we start building our database. If this table has foreign keys to other tables, the other tables have to exist first before we can say, hey, it must reference an organization and it must reference a student when we talk about membership. Okay, so it's existence dependent on those other tables. If there is no dependency there, you say it's an independent, or existence independent. Sometimes you call it a strong entity or a regular entity. Just kind of depends on some of our terminology here. And then we can also talk about that relationship strength when we're looking at our relationships here. So we can have weak relationships, which are most of our relationships here are probably going to be weak relationships here. The idea with a weak relationship is that it has a foreign key. That's all it is. It's a one-to-many. That's very common for us to have these weak relationships with these one-to-manys. You'll have a strong or an identifying relationship if the foreign key is part of the primary key, part of a composite primary key. So if we said, hey, my primary key is the foreign key of the student and the foreign key of the section. If this whole thing here was the primary key, we would have strong identifying relationships with student and section. Right? And again, this just depends on how we're designing it. I'm partial to having every table have its own identifier, right, instead of doing composite keys, but there's no wrong, it's not wrong to do it this way, because you can't enroll in the same section more than once. Now, you can take the same class more than one time across different semesters, but again, that's kind of handled here, right, because we have this class entity over here, or course, and one course will have many sections, but one section will have one course. So we're not saying you can't take the same course more than once, we're saying you can't take the same section more than once, which I think makes sense. So maybe having this being a strong or identifying relationship makes sense here. And our primary key can just be the composite foreign key student of student and foreign key of section. That could work. Again, it's just depends on how we want to design it here. But you don't necessarily will often use that foreign key from another table in your primary key. So that's why it's called out as a weak or non-identifying or strong or identifying relationship between them. So that's just when we look at how those entities relate and the types of relationships, we get a lot of that extra terminology. So we're considered a weak entity, right, if we're existent dependent, or if our primary key is including the other's foreign key. Right, will be a weak entity. Because right, we're dependent on the other one, on one of those strong or regular entities here. You can do all sorts of notation here. Now, when we look at this crow's foot notation, you don't have to have enrollments, right? So really, it's probably like 0 to n here, n as many as you want, or star. Again, I'm partial to star from the UML notation, but if we're doing our crow's foot, right, 0 to n, you can be listed as a student without being required to enroll in a course right away, right? When you apply, we're going load all your information, we put you in the database, we have all your information, but you haven't enrolled for a course yet. So you're not required here to participate in this. And with sections, when we create sections, again, that is optional, right? It's probably 0. Right? We will have 0 students when we first add a section, and then we start loading those entities. And again, some of that comes to, it's difficult to enforce this at the database level. This cardinality sort of rules are typically at the application level. So we're saying, hey, whatever application is working with our database and working with the data, we need to enforce it at that level. Again, it's more of a, when we implement our database and create it, we need to know, hey, this is a weak entity here. So I need to create the strong ones first. So when I'm making all the tables, I need to create student, and actually I would create course, and then I would create section, and then I would create enrollment, because they have all of those relationships there. Right? So I can't reference a section until the section table exists. I can't reference a student until the student table exists. So we need to make sure we're doing it in the correct order when it actually comes time for implementation, which will actually be the much more interesting part of the course. I know a lot of this designing here it's a little dry, it's very conceptual, it's not very hands-on. Aside from drawing a little bit here, there's not a lot of stuff to practice with because it's so conceptual. So we'll get to the fun stuff soon, I promise. And then when we talk about these relationships, there's also this idea of participation, right? Whether or not it is optional or required, right? If you have to have a relationship, it's required. If it's optional, right, you don't necessarily have to. So we would typically note that here in our crow's foot notation with a 0 on the foot. If it's required, we would say, hey, that's a 1, must be there for a section. And again, most of our relationships tend to end up being optional. because it just works a little bit nicer here to say, if you want to create a new course that hasn't been offered before, we can't put it in the database without a section if you're saying it's required. So typically the optional ones just work a little bit nicer here for us. So we'll use that in our notation. That's the participation of how those relate. All right, why don't we pause here? We'll pick it back up in the next section.